so this is our video lesson for 16.1. Alright, so today we're going to start chapter 16 together through video because, of course, you know I like to spend most of my time in class on the math sections. So that way we have more time to do that because a lot of you have trouble with math, especially because you don't want to write those units. Alright, so we're going to do 16.1 today on video. I apologize if I keep coughing. I've literally made all the video lessons for this semester on the same afternoon when I had a cold. So my throat is getting very sore right now. Alright, so anyway, let's go ahead and start section 1. So we're going to talk about solutions. So solutions are homogeneous mixtures that can be solids, liquids, or gases. So what's homogeneous mean? Remember, homogeneous mixtures, you cannot see the difference. Okay, so Windex, it just looks like a blue liquid. You can't see the difference in the base floating around and the, coloring and the scent and the water. You can't see all the differences. And like I said, they can be solids, liquids, or gases. Mixtures can be solid, like sterling silver is a mixture of metals. They can be liquids, like I said, like Windex. They can be a gas, like air. Air is a mixture of different gases, and we can't see the difference in it, so it's a solution technically. Now, the important thing to remember about a solution is the solvent dissolves the solute. Okay, I have a lot of students who get those words mixed up. The solvent dissolves the solute. So, for example, if I was making Kool-Aid, what would I plug in here? The water dissolves the Kool-Aid powder. So the solvent would be the water, the solute would be the Kool-Aid powder. It doesn't make any sense for me to say the Kool-Aid powder dissolves the water. So that's a way you can tell which is which. The solvent dissolves the solute. So if you put the actual parts in here, the water dissolves the Kool-Aid powder, then it makes it a little bit easier. So, 3 factors determine the rate at which a solute dissolves, because some things, we know this, dissolve a little bit faster than others. And those are stirring, sometimes referred to as agitation, temperature, and the particle size of the solute. So that's what we're going to talk about in this section, is how do those things affect how fast something will dissolve. Because, as with most things, we always want things to happen pretty fast. We don't want to have to wait around. So we don't want to have to wait around to dissolve stuff in a chemistry lab. We want to hurry up and get it done. Alright, so let's look at these 3 things. So the first one is stirring or agitation. So, stirring a solution speeds up the rate of dissolving because it disperses the solute and brings the solute in contact with the solvent particles. So this right here is the most important thing, because on the test, when I ask you, why does stirring help a solute dissolve faster? You say because you speed up the particles. Y'all, particles are already moving so fast that I don't care if you are the world record holder of fastest stirrer, you are not stirring anywhere as fast as those particles are already moving. So you are not speeding them up by any means, okay? What you're doing is you're spreading them out. Because if I dump a solid in a liquid, what happens? It sits right there at the bottom. So if I stir it up, where does it go? It goes everywhere. It disperses it. It spreads it out. That's what allows it to dissolve faster. So you're not speeding up the particles. You are just spreading them out. That's all that's happening. Okay, so that's how stirring speeds up dissolving. Next thing is temperature. Increasing the temperature of the solution usually increases the rate at which the solid solute dissolves because the particles are moving faster. So, dissolving is all about particles moving, and we'll talk about this a little more later. It's about particles kind of surrounding each other. We'll discuss that later. So again, the faster those particles move, the faster those liquid particles can kind of break that solid down. Okay, so temperature increases the rate of dissolving because, of course, the particles are moving faster. So it can break that solid down a little bit faster. And then last one, of course, is particle size or surface area. Again, sometimes you'll hear it called either one. So dissolving only occurs at the surface of the particle. So when you put something into water, well, let's say this is a big old sugar cube, and this is water. The water molecules have to peel away one layer at a time of the sugar cube before it can even get to the center. Whereas if we crush the sugar cube up, then notice there's not as much middle here. So the water molecules can attack more of it quicker. Okay, that's why we crush things, is to help speed that process up. So, since again dissolving only occurs at the surface, the smaller the particles, the more surface area that the solvent can dissolve. Okay, so remember, 3 ways to speed up dissolving. Stir, which disperses it, heat it, which speeds it up, or crush it, because that will increase the surface area or make the particles smaller. Okay, and y'all, these are 3 things you should have already known. If you're trying to dissolve a sugar cube at home, you probably crush it first, you dump it in some water, stir it up real good. If it still didn't dissolve, easiest thing to do is heat it. Okay, so I know you already know this stuff. So this should just be a review. So, solubility. Solubility is the amount of solute that dissolves in a given quantity of solvent at a specific temperature. Okay, y'all, you know this, especially with sugar and sweet tea. If you're like me, you want a little bit of tea with your sugar. You can't dissolve as much sugar as you want. Eventually, it's just going to settle at the bottom. You've reached the solubility, the maximum amount that will dissolve. So, solubility is often expressed in grams of solute per 100 grams of solvent. So it might be that 20 grams of your solute could dissolve in 100 grams of your solvent, and after that you can't dissolve anymore. Okay, so that's all solubility tells us, is the ability of a solvent to dissolve solute. So how much can we dissolve in there before it won't hold anymore? So let's talk about some different types of solutions. And again, y'all, this is probably review. You should have learned this in physical science. Okay, I have the same pictures on my physical science PowerPoints that I have on my chemistry ones. All right. So, first is unsaturated. An unsaturated solution contains less than the maximum amount of solute at a given temperature. So we've added some, but we haven't added the maximum amount yet. So then what happens if we add more? Well, if you add more, because it's not full yet, that extra solute will also dissolve. Okay, so that's what this picture is showing us. All right, it's showing us blue, so the coloring is showing us how much is dissolved. So right here, we don't have much. We add a little bit more, so it dissolves and the color of the liquid gets darker. All right, so unsaturated has less than the maximum amount. Saturated, on the other hand, has the maximum amount of solute already. So we added solute until we couldn't add any more. And notice it's at a given temperature, because we'll discuss how all this changes with temperature. If you add more solute and a solution is already saturated, it won't dissolve. It'll just settle at the bottom. Okay, so if you look at this picture, we got saturated, we add more, it doesn't do anything. It would just end up settling at the bottom. So that's when, like, you're adding sugar to your tea or something, and you're stir, and you think it's dissolved, but then you wait a few minutes and it settles back at the bottom. So you stir it again, you think it's dissolved because you spread it out, but then it settles at the bottom. It's saturated at that point. You can't get any more in there. I mean, there are ways, but at that temperature, you can't get any more in there. So let's talk about what are those ways. Those ways are supersaturated. A supersaturated solution contains more than the maximum amount of solute. Now you might think, well, how could you possibly have more? We're going to talk about that. All right, so it has more than the maximum. So unsaturated has less than the maximum. Saturated is the maximum, and supersaturated is more than the maximum. A supersaturated solution is extremely unstable. Whenever you have more of something than you're supposed to, that's not going to be very stable. So what happens if you add more then? Okay, well, let's look at the picture. When we add more, it gets bigger. The solid part gets bigger. So it doesn't dissolve. It doesn't just settle at the bottom. The solid part gets bigger. So if more solute is added, then a fast recrystallization of the previously dissolved solute occurs. Now, y'all, the only way you can fully understand what has happened here is to see an example in class. So I'm going to show you an example with sodium acetate. And once you see the example, you'll know exactly what I'm referring to here. But up until now, you probably can't really imagine in your mind what I'm actually meaning. So I will show you an example of that in class. All right, so remember, unsaturated is less than the max, saturated is the maximum, and supersaturated is more than the maximum. And remember, supersaturated is very, very, very unstable. All right, so how do you make something supersaturated? Well, remember, solubility tends to increase with temperature. So that's why if you want to make super sweet tea, you add the sugar when the tea is hot. You don't add it when you have iced tea at that point. You add it when it's hot. Okay, because the higher the temperature, the solubility increases. So what you do is you heat something up so you can dissolve more. Then, a supersaturated solution is made by heating the solvent, adding the maximum amount of solute at that elevated temperature. Then, if you carefully cool the solution, I say carefully because y'all, these things go wrong all the time. Like sometimes a bit of dust might fall in there and then it totally ruins the whole thing. If you carefully cool the solution, then you can form a supersaturated solution. And what happens is you carefully cool it down and all that excess solute stays dissolved. But again, it's unstable. So bumping it, dropping something into it, trying to stir it, a lot of those things will cause it to recrystallize and come out. Because again, very unstable. But that's how you make it, is you heat something up, dissolve extra, carefully cool it down, and sometimes it will stay dissolved. So let's talk a little bit about liquid solutions. So two liquids that will dissolve each other are called miscible. So for example, vinegar and water. You can add vinegar and water together, they will mix together, they are referred to as miscible. However, not all liquids mix together. Two liquids that will not dissolve one another are called immiscible. So an example would be oil and water. I know this says oil and vinegar, but I didn't notice that the picture wasn't entirely right until afterwards, and I think we all know I'm not going to go back and change it. So just pretend like it's oil and water. Alright, so when we mix oil and water, it forms layers. They do not mix together, so they're referred to as immiscible. So two liquids that mix together are miscible. Two liquids that will not mix together are immiscible. Okay? And those would be examples of a liquid solution where we mix more than one liquid together. So let's talk about some factors that affect solubility, because sometimes, like I said, even though we have a threshold of solubility, we might want to dissolve more. So what can we do to help that? Alright, now the difference in this and what we just talked about a few minutes ago was a few minutes ago we were trying to speed up dissolving. Here we're trying to dissolve a larger amount. Okay, so when we're trying to affect the solubility of a solid, we really have one option, and that's temperature. As temperature increases, the solubility of a solid tends to increase. So if you look at this graph, I hope you can see it. I don't know how well you'll be able to. Most of these lines, they go up. And this is temperature and this is solubility. So as we heat it, the solubility increases. Now not all of them do, but most of them do. Like here we have one that's kind of flat. Here we have one that actually goes down. Alright, now another way you can affect solubility but not with a solid is pressure. A change in pressure does not affect the solubility of a solid. Okay, think about it. If you apply pressure to a solid, does anything really change? No, because the particles can't really get any closer. So if it doesn't change, then how is it going to change solubility? Okay, so when you're trying to change solubility of a solid, you can increase temperature, but pressure doesn't really make a difference. So now let's talk about a gas. So, who in here has ever seen a gas dissolved in a liquid? Okay, well, I guarantee that you have. And you drank one, probably drank one pretty recently. Any carbonated beverage is, like Coke, is a gas dissolved in a liquid. It's carbon dioxide, carbonation, dissolved in the liquid, the water. As you can imagine, that doesn't just happen super easily, because if you try to put a gas in a liquid, what happens? It just bubbles right out. So how do they make this happen? Well, there's two ways that they can make it work: temperature and pressure. Alright, so as temperature increases, the solubility of a gas actually decreases. The gas particles need to be as slow as possible to force them into the liquid. Okay, so y'all think about it. A liquid's kind of like this, kind of moving around. The gas is like this. If we try to put that together, it's not going to work. So if we can slow the gas down, we can kind of force it to dissolve into that liquid. Okay, so for solids, we want high temperatures, but for gases, we actually want low temperatures. We want to slow them down. The other way is force the gas in through pressure. Are gases affected by pressure? Yes, because we can compress them. We can squeeze the particles closer. So, if we apply pressure, the solubility of a gas tends to increase because we are forcing the particles in the liquid. So remember, for gases, we're trying to force it in there. So we want it cold and slow, and we want to push it in there with a lot of pressure. That's why when you buy a Coke, if you squeeze the bottle, it's really, really tight. You open it, what do you hear? You hear the psh. That's the pressure releasing. Then if you close it back and squeeze it, it's a lot more flexible. Okay, because there's a buildup of pressure in there to keep that carbonation in there. Otherwise, by the time you get the Coke, carbonation is going to all be at the top. You're just going to have liquid at the bottom. It'll be flat. Alright, so let's move on to section assessment. So what units are usually used to express the solubility of a solute? It's usually grams of solute per 100 grams of solvent. Grams of solute per 100 grams of solvent. Alright, and then last one, What would you do to change a saturated solution into an unsaturated solution? Now, lots of students, they tell me an answer that technically could be right, but it's just not real, you know, it's not real possible for you to just do if you're doing this at home. Alright, so if we have it saturated, so it's full, and we want to make it unsaturated, a lot of students tell me they'll take some of the solute out. Well, y'all, if you accidentally add too much Kool-Aid powder, and then you realize you did, how are you, and it's already dissolved, how are you going to take it out? That doesn't make any sense. What do? If you add too much Kool-Aid powder and then you taste it and you're like, oh my gosh, this is too strong, you don't take Kool-Aid powder out. What do? You add more water. So in this answer, if we want to go from saturated to where it's full to unsaturated, we would add more solvent. Okay, the reason we don't want to say water to this question is we don't know what the solvent is. It didn't tell us. Okay, so for number 2, you would say you would add more solvent. Okay, so again, think back to the Kool-Aid. You add too much powder. Let's say you buy one of those little packs. Those little packs are supposed to make like a big pitcher. Let's say you thought it was supposed to make 1 glass. So you dump all of it in the 1 glass, and then you taste it, and it's terrible. You can't take the Kool-Aid powder out. You just pour the glass in a pitcher, add more water. Okay, so to go from saturated to unsaturated, you add more solvent. All right, and that is it for our introduction to solutions. Get ready for the math. It's coming.